if I divide 1 by cos square x, 1 upon cos square x, second square x into dx as it is. This is first is 1 upon cos square x, second square x, 1 upon cos square x, second square x, plus 3 into tan square x. Why? Because sin square x upon cos square x, tan square x. Now let me further resolve it by changing sec square x into tan inverse x. It will be 1 plus tan square x plus 3 tan square x. It will be nothing but second square x dx upon 1 plus 4 tan square x. Now let me substitute, putting tan x equal to t. Therefore differentiating it with respect to t, we get second square x into dx upon dt into 1 or second square x into dx equal to dt. Substituting this value, what do we get? Sin of integration dt divided by 1 plus 4t square. If I take 4 common, it will be 1.4 sin of integration dt upon, this is 1 upon 2 whole square, because it will be 1.4. 1.4 can be written as 1.2 whole square. This is t square only. Now this is again t square plus a square or f square plus a square. It will be 1.4 into 1.a. Upon a is 1.2. 2 will come in the numerator. A is 1.8 into tan inverse t upon 1.2, that means 2t only, plus constant of integration. So this will be 1.2 but 2 into tan inverse 2 into tan x, for t is tan x here, plus constant of integration. This is final answer. Question number 5. Okay, this is question number 5. Let me talk about question number 6 now. So question number 6. What does it say? Let's check. Now question number 6. Question number 6 is there. Okay, so this is sin of integration 1 upon 1 plus cos square x into dx. Again, dividing numerator and the denominator by cos square x. We get, here it would be second square x. Why? Because 1 upon cos square x numerator is second square x, divided by, this will be second square x, again 1 upon cos square x, plus cos square x upon cos square x. Okay, so this way into dx. Now again changing it into denominator, change for tan square x, which is 1 plus second square x, 1 plus tan square x, plus 1 here. It will be nothing but second square x into dx, second square x is angle, okay, divided by 2 plus tan square x. Okay, now putting tan x equal to t, putting tan x equal to t, differentiating it with respect to t, we get second square x into dx upon dt plus 1. So dx is a function of t here. It will be second square x into dx equal to dt. Okay. Therefore, substituting the values, what do we get? We get here, this is gt over 2. 2 can be written as under root 2 whole square plus b square. This is again x square plus a square, or a square plus x square. It will be 1 upon a means under root 2, into tan inverse t upon under root 2. T now substitute the value plus constant of integration 1 upon root 2 into tan inverse t is tan x, or 1 upon root 2 into tan x, plus constant of integration. This is the question number 60 here, we have done question number 6. Okay, now let us talk about the next question. Question number 7. What did the question number 7 say? Let us talk about question number 7. We have question number 7. It is 1 upon, sine of integration, it is 1 upon 2 plus sine 2x dx. Okay, if I write here 2 into, because we know that sine square theta plus cos square theta is equal to 1. Okay, therefore substituting here 2 into, if I write 1 upon 2 into sine square x plus cos square x, no change, because this is 1, 2 into 1 plus sine 2x is 2 sine x into cos x into dx. Alright, now dividing it by cos square x, dividing numerator, since dividing numerator and denominator by cos square x, we get here, this is secant square x in the numerator 3x divided by 2 into, this is tan square x first, plus it will be 2 only, because 2 cos square x upon cos square x, only 2 tan x. Okay, so this is 2 tan x. So 2 is throughout common. If I take 2 common throughout, here, that can be taken, take 1 upon 2. Sine of integration, this is secant square x into dx divided by tan square x plus tan x plus 1. Only 1. Now substituting, now putting tan x into t again, tan x equal to t. Therefore differentiating it with respect to t, we get secant square x into dx. Okay, into dx equal to dt. Substituting these two values here, we get this dt divided by 2, okay, this value t square plus t plus 1. Alright, sorry, 1.2 is also there. It's 1.2. So 1.2, that will make it perfect step, the denominator dt upon, this is t plus half whole square. If I write it as t plus half whole square, then what it will be? This is t square plus 2a into b, that means only t square plus t plus 1.4. So we have added here 1 plus 4. But subtract here from 1.4. No change now. It will be 3 by 4. So finally we obtain this is 1.2 sine of integration dt upon t plus 1.2 whole square. Plus it will be 3 by 4, that means root 3 upon 2 whole square. Again this is x square plus a square. Integration of this will be 1 upon a here, root 2 will come in the numerator, sorry 2 only, sorry. There is root 3 upon 2, that means 2 only. 2 upon root 3, 2 plus 2. Tan inverse will be tan inverse 2t plus 1 upon root 3 only. Why? Because root 3 upon 2, this is 2t plus 1 upon 2 cancel. This is the final value. That's constant. Let me further summarize this. It is 1 upon root 3 tan inverse. It is 2 into tan x plus 1 upon root 3 plus constant of integration. This is the final answer. Okay, so question number 7 we have done. This is 7th question. This is also solved. Now let me take the 8th question. Now question number 8, what does it say? Let us talk about question number 8 now. So let us take question number 8 now. Question number 8, what does it say? Okay, this is Sin of integration dt upon 1 upon a square minus b square into cos square x into dx equal what I'm writing. This is dx. This is dx. Or I could write it as 1 upon into dx. For differentiating it with respect to x, for integrating it with respect to x here. So variable is x. Here a is greater than b. No problem. A is greater than b. So here again dividing numerator and denominator by dividing numerator and denominator by cos square x. We get what do we get here? This is second square x into dx because 1 divided by cos square x, 1 from cos is second square x into a square into second square x. Why? Because a square upon second square x. So upon cos square x is equal to a square into second square x minus b square only. Why? Because cos square x upon cos square x is 1. This is now let me change the denominator of second square into 10. It will be a square into 1 plus 10 square x minus b square. Now putting, let me put, now putting 10x equal to t. Therefore, second square x into dx equal to dt, differentiating it with respect to t. We have obtained this. Finally, we substitute the values. It will be dt oblique. Okay, this will be a square plus minus b square and plus a square. Let a square into b square plus a square minus b square only. Why? Because if I write here 1 plus t square multiplied by a square, it will be a square plus a square t square, a square t square plus a square minus b square. Okay, now if I divide it by or take a square common, 1 upon a square out, dt divided by t square plus a square minus b square upon a square. What it will be? It is nothing but 1 upon a square. Further resolve it, write in the simplest form, plus it is under root a square minus b square upon a whole square. This is x square plus a square time. Again, 10 into this 1 upon a square into 1 upon a. That means a will come in the numerator upon under a square minus b square into 10 inverse t upon this. It will be a into t upon under root a square minus b. Because constant of it is 1 we cancel out. What do we get here? This is 1 upon a under root a square minus b square 10 inverse. Now putting the value of t, which is 10x, it is nothing but 8 10x divided by under root this is a square minus b square plus constant of integration. Final answer. This is the final answer here. Question number 8 we are done. Okay, now let us talk about next question. What the question number 9 say? Let us check. Okay, now question number 9. Let's check here. Question number 9 says what? Okay, 1 upon sin of integration. This is 1 upon a square into cos square x plus b square into sin square x into dx. Okay. Again dividing numerator and denominator by cos square x. Dividing this, we always write like this, step by step. Dividing numerator, this is short form. Okay, numerator and denominator by cos square x. We get, what do we get here? This is sin of integration Here it is second square x into bx. Cos 1 divided by cos square x into cos second square x. This is a square only. Because cos square x and cos square cancel out. This is b square into tan square x. Why? Because sin x upon cos x is tan x. Sin square x upon cos square x is tan square x. This one. Now putting tan x equal to t. So putting or substituting, we are putting tan x equal to t. Therefore, differentiating it with respect to t, which we always write. Differentiating it with respect to t. So we get here, nothing but second square x into dx equal to dt. Okay, so what will we get? This is sign of multiplication. This is dt upon a square b square into t square. Okay, this is a square plus b square into t square. Now take b square common. So because we have to make independent t square, whatever the variable, that variable should be made as independent. For that we have to take b square common. So it will be dt upon a square upon b square, that means a upon b whole square plus c square. Now it is easier to integrate, apply the formula now. T square plus a square will be 1 upon b square into 1 upon a. Upon a means b upon a. It will be 1 upon a upon b. B will come in the numerator into tan inverse t upon a upon b, that will be b into t upon a, is constant of integration. Finally it will be b cancelled out, so 1 upon ab into tan inverse b into t. T means tan x upon a, is constant of integration. This is your final answer. Question number 9 we have done. Okay, now let us talk about the next question. Let us take next question of 10th question. What does 10th question say? Let me check. So question number 10, what did it say? Okay, now question number 10 here. Sign of integration. This one. This is 1 upon a square minus b square into sin square x. 1 upon a square minus b square into sin square x. Okay, into dx. Here a is greater than b. Here also a greater than b. Alright. So again dividing numerator and denominator by cos square x. Dividing numerator and the denominator by cos square x. We get what do we get here? So we get here, this is nothing but second square x into dx divided by, okay, this is a square into second square x minus b square into tan square x. Why? Because sin square x upon cos square x, that means tan square x. Okay, now changing this second square x into tan square x. So tan square x dx divided by this a square into 1 plus tan square x minus b square into tan square x. Okay, now putting, let me put here, putting tan x equal to t. Okay, differentiating it with respect to t. Differentiating it with respect to t. We get, it is second square x into dx equal to dt. We put this directly. What do we get here? This is dt only a square into 1 plus t square minus b square into t square. This is b square into t square, and this is 1 plus t square. Right? Let me collect the value of t square. It will be dt upon a square. Okay, This will be a square plus t square. If I take common, it will be a square minus b square. What is there? If I take a square minus b square common, it will be 1 upon a square minus b square out. Tan of integration dt upon, it will be a square upon a square minus b square plus t. So this is a upon under root a square b square whole square. Okay, so it can be directly integrated. This is 1 upon, let me write a square minus b square is already into 1 upon a. A is here, this is a upon under root a square minus b square will come in the numerator, a will come in the denominator. It will 1 upon a upon under root this, under root a square minus b square will come in the numerator into tan inverse t upon this value will be a into t upon under root a square minus b square. Why? Because this will be, let me write this, a upon under root whole square. Now it is okay. So if I put a is a upon under root a square minus b square. This will be a 1 upon a upon under root this. So this will come in the numerator. Similarly here it will be t upon a upon, sorry, what am I doing? This will be t upon a. T upon a means a will come in the denominator. Sorry, this is not like this. Under root a square minus b square into t upon a. Okay, this is okay. Alright, so this is nothing but t upon a. T upon a is a upon under root this. So this a is in the denominator and this will come in the numerator. Now let me substitute the value of t plus constant of integration. Because it is indefinite integral. Now here this under root will come in the denominator. So this is 1 upon a under root a square minus b square. A square minus b square. Okay, 1 upon a under root a square minus b square into tan inverse this value. So this is under root a square minus b square into tan x upon a plus constant of integration. This is here tan. This is tan inverse this value. Final answer is this. This is the final answer. So this is question number 10. Okay. Now 11th onwards, these questions are definite integral. So constant will not be there. Now let me write next question, or let me take the next question. Or this is about next question. What is that? Question number 11, which looks to be your definite integral. Definitely okay. Let us take all these questions which are of definite integral. Question number 11 here, plan of integration 0 to y by dx upon. We have to show that this answer is equal to pi upon 0. Okay, so this is dx upon under root, that is only a square into cos square x plus b square into sin square x. We have to prove that this is equal to pi upon 2ab. We have to prove a to b. Just to show that this is equal to this. Let us take left hand side here. This is left hand side equal to this 0 to pi by 2 dx upon a square into cos square x b square into sin square x. Okay, now dividing numerator and denominator, the same value, dividing numerator and denominator by cos square x. We get here we get secant square x in the numerator dx divided by this a square into cos square x upon cos square x is 1, that is a square only, b square into tan square x it will be. Why? Because b square into sin square x upon cos square x, sin square x upon cos square x is tan square x, and this a square into cos square x upon cos square x is 1. This is a square only. A square into 1, that is a square. Now this numerator, if it is divided by cos square x, 1 upon cos square x equal to secant square x. This is clear. Now let me substitute tan x equal to t. Putting tan x equal to t. Putting here tan x equal to t. So we get differentiating it with respect to t. Differentiating it with respect to t. So we get here secant square x into dx equal to dt. Finally, okay, limits are over there, 0 by. Okay, let me convert this into the limits into t, no problem. So if I substitute here tan x equal to t, okay, so if t is pi by 2, so the x is pi by 2 here, first limit, for left, then x equal to pi by 2, tan pi by 2 equal to t, and this is infinity, but tan 90 is 1.0, that means infinity t. And when x is 0, and for x equal to 0, t is equal to tan 0, that means 0, 0 to infinity, that means 0 to infinity, this is dt upon a square plus b square into t square, this is a b square into t square, for tan x equal to t. Okay, limits we have changed here. Finally, this will be, if I take b square common, if 1 upon b square out, infinity using 0 to infinity, then dt upon a upon b whole square, try to understand. This will be a square upon b square. That means we can write it as a upon b whole square plus t square. Now the integration, same tan inverse. So this will be 1 upon b square, which is already there, into 1 upon a. A is a upon b, that means a will come here and b will come in the numerator. 1 b cancels out. Into this tan inverse t upon a upon b, that means b into t upon a upon b. Okay, that is the value. Finally, if I substitute, putting the value, the limits are 0 to infinity. So it is first is 1 upon ab, so 1 upon a into b. B is remaining here. But after cancelling 1b, we are left with b in the denominator, b into a. ab. Tan inverse, if I put the upper limit, is tan inverse infinity, t infinity, b into infinity upon a means infinity on. So tan inverse infinity minus 1 upon ab into tan inverse 0. Infinity is for pi by 2. It will be nothing but 1 upon ab. It is for pi by 2. Pi by 2, the value is infinity, 10 pi by 2. But suppose tan inverse phi, infinity is equal to theta. Tan theta, theta is what? Tan theta equal to infinity, that means theta pi by 2. Pi by 2 minus this is 0 here. This is 1 upon ab into 0. That is pi upon b, only 2a into b. This is 2a into b. This is the right hand side has been proved. Finally, it has been proved. This is the right hand side. In sounds, you may say proved. Okay, so finally, this is the proved answer. Question is proved. Now, this is the 11th question. Let us talk about the 12th question. What is the question number 12 say? Let us see. Let us see what is the 12th question. Okay, question number 12 now. I think that is also definitely there. Yes, that is also definitely sum of integration. Limits are 0 to pi now. Okay, this is dx upon, okay, 3 plus 4 into cos square x. Also dividing numerator and denominator. Dividing numerator and denominator by cos square x. We get, what do we get here? It will be 0 pi limits 1 upon cos square x secant square x in the numerator into dx divided by 3 into secant square x. That's 4 into only 4, but 4 into cos square x upon cos square x. Cos square x is cancelled out, so it is only 4. Let me change the denominator to secant square into tan square. It is secant square x into dx divided by 3 into 1 plus tan square x plus 4. Now putting tan x into t. Therefore, differentiating it with respect to t, we get it will be secant square x into dx equal to dt. Simple, repeated step. This is. It will be okay. Now limits would also be changed. So what is tan pi? And pi is 0. Sin pi is 0. Cos pi is 1. But 0 is 0. And for 0 it is 0. 0 is also 0. The limits are 0 to 0. I'm sorry. It means 0 is the answer here. There are no limits. If I substitute 0 to pi, let me take 0 to pi by 2 only. Otherwise, it is 0 to 0 limit. That is not possible. You take here pi by 2 limits. Limits are pi by 2. Then it is limits can be changed then. So for, let me write here. For x equal to pi by 2, x equal to pi by 2, tan pi by 2 equal to t, the t equal to infinity. 1 from 0, that means infinity. Again, when x equal to 0, and for x equal to 0, then 0 is 0, so t equal to 0, t equal to 0. For x equal to 0, t equal to 0. This is 0 to infinity again. Secant square x dt upon 3 into 1 plus t square plus 4. That will be 0 to infinity dt upon, what is this? 4 plus t 7. It will be 7 plus 3t square. 3 into t square plus 3 plus 4, 7. Now let me take 3 common. It will be 1.3 out. 0 to infinity, which is dt upon 7 upon 3 means under root 7 upon 3 whole square plus t square.